Hey everybody, it's Jay Henry. In this video, I'm going to continue the work that we've been doing on creating a computer vision model by adding a service layer based on Flask, which is a Python kind of framework for RESTful services. Um, and it's going to load up the model that we trained in our last video and use it to make some predictions based on inbound image data. Before we get started, I want to draw your attention to some changes that I made. After the last video, we trained a model and it was tracking at like, I don't know, 93% accuracy. I went back and simplified the model quite a bit, took out a ton of blocks. Just to speed up training, what I found by taking out the blocks is that I can have far fewer blocks and still get just as good of accuracy with the model. So I greatly simplified it, which speeds up training, allows us to have higher resolution images without eating up too much memory, and just makes the whole thing a little bit more efficient. The other change I made is that rather than saving the model format and weights separately in JSON and H5 files respectively, I'm just saving the entire model in a single H5 file. And that'll make it easier for what we're going to do here, which is to load up this model and use it to make some predictions. So without further ado, I think the way I want to structure this, I'm going to create a, yeah, that's cool. I'm going to create a services directory and use this to create the service that's going to make the predictions. So this isn't going to be a very complicated service. It's really just going to have a single service layer which will accept the HTTP requests, and then probably something I like to call providers. And I'll create a folder for that. And this is going to be the workhorse of this service. So this will be where we actually load up the model and make the predictions. So let's call it maturity predictor.py. That's good. And in here, we're going to basically load stuff up. So keras.models, it has a helper function called load model, which we'll use to load the H5 file, which contains both the format and the weights. And then we'll use numpy to, and I just prefer that. It's sort of shorter and simpler. NumPy we'll use to create our matrices that we're going to pass into the model. Now I'm going to declare the model outside of the functions that we declare, and I'm going to use it as a global kind of variable. You could get much more sophisticated and create a class that implements a singleton pattern, or a class that implements a static method that creates the model. But I'm just going to do it a really simple way here. And the reason I'm doing this is because loading up the model is an expensive operation. The saved H5 file with the weights and the format tends to be fairly large, and so loading it up is, like I said, it's an expensive operation, and we don't want to incur that delay every time we want to call the service to make a prediction. So I'm just going to load it once, and after that we'll just use it. And so basically what we're going to say is, like, if it's none, if it's null, if it's nothing, we will load it. And we're going to create a function called load model, probably load trained model. Makes more sense. And we'll declare that down below. Actually, let's do that now. I usually prefer to work bottom up, so let's do that here. So load trained model, Don't need any arguments because we're just going to use the location where we saved it. And so if we look in here, we're going to use this path. Obviously, if we wanted to put this path in some kind of configuration so that we didn't have to declare it in two places, that would be better, but I'm not going to do that for this video. And here, this is why we had to call it load trained model. If we had tried to redeclare load model as a new function, Python would not have been happy with us. All right, so let's do that. Yeah, that should be all there is to it. I don't think we need any more than that. And there's that. And the other thing we're going to need to do is this image matrix that we pass in. It should be a three-dimensional matrix. It should have height, width, and channels, and they'll have 3 channels if it's a color image. But if you remember from our last video, we were passing in these image matrices in batches, and so the model that we trained is actually going to expect the data that we pass in to be a 4-dimensional matrix where it has the batch size and then the height, the width, and the channels. So we need to actually create that batch. I think this is the right place to do that formatting. I don't think we need to do it at a higher level because this is really the only level that will care about that structure. So I'm going to create a function called createImageBatch, passing in the image matrix. And we're going to use NumPy to create, basically we're going to add a dimension to our matrix. And the way we're going to do that is use the full function. And the full function is going to take 2 arguments. The first one is going to be the shape, and the shape is we're going to declare, how many dimensions there are in the matrix. So we're going to say we have 1 image, and that 1 is going to be how many images we pass in at a time. And then we're going to use the image matrix that we have to give it the rest of the parameters. And really all this does is add a dimension to our image matrix. Now, this is the best way that I found to do this. It was the most concise way to do it. However, I just have this nagging feeling that there's a better way to do it. So if you know of a better way to take a 3-dimensional matrix and turn it into a 4-dimensional matrix, let me know in the comments, because I would love to find a way that makes more intuitive sense. The last argument here is going to be 0. So basically what we're going to do is we're going to create this 4-dimensional matrix, and we are going to populate it with all zeros. And then the way that we are going to push our image matrix into it is we're going to say that the first element is our image matrix. And what it's exactly the same as creating a batch of images, but it's a batch of 1, and we just make sure that the first element in there is our image. And that's it. Then we'll return that batch, and now we should have everything we need to finish this method. And so we're going to batch equals create image batch, passing in the image matrix, and then we're going to actually get the prediction. And we're just going to call model.predict, passing in our batch, and then we'll return the prediction. And this should be a vector or array, whatever you want to call it, that had, if you remember when we trained the model, there was a softmax activation at the end of it. So all of the numbers that are going to be returned in this prediction should add up to 1, in essence. I think that's good. We'll do a bug check when we actually call this. So we've got services. I think at the root of services, I will create, not directory. I don't need a directory. No, I don't need that. I need a service. I like to call it service .py or .js, whatever it is, because it tells me that it is a interface to a protocol. So, for example, this is going to be an interface to an HTTP or HTTPS protocol. But if you were using something like gRPC or sockets, or raw TCP sockets, or some other protocol, you could have a file per protocol that kind of does the handshaking for that protocol, but the underlying processing that you're doing with the data that comes out of that protocol is in a common module that you can reuse. And that's just kind of how I like to structure it. And I think when you look at this after we've written it, you'll well, hopefully, if I do a good job, it will just manage grabbing the data out of the protocol and doing the handshaking. Like I mentioned before, we're going to use Flask, and I will leave a link to the Flask project in the description. It's a great Python project for creating RESTful services. And we use request. And I think we'll also need JSON-fi. We're going to take our data and turn it into JSON before we return it. We're going to need some Keras utilities here to load the image and format it in our matrix so that we can pass it in a format that's understood. So we'll use load image and then image to array. Yeah, it's the full word, array. We're going to import UUID, and what we're going to use this for is creating unique file names for when we get the image data and we want to save it to disk and then load it up real quick. Using the Keras utilities, we want to make sure that the names are always unique in case we have many people calling our service at the same time, potentially with the same file name. Yeah. And then now we're going to import the code that we just wrote, the predictor, and that's what we're going to use. Nope, that's what I wanted, I promise. Cool. And then we're going to use Flask name. And you'll see when we start this up how that's going to get set. We're basically going to set a command line argument that's going to tell us the name of the app. And now we're going to declare the root, and this will be the RESTful kind of resource name that we will use to access this code. And so now here I have a conundrum, because I could say plant maturity /predict, and that will tell me that the resource is plant maturity, and what I'm trying to do is predict it. But it might make more sense to say that the resource is prediction, and then the type of prediction is plant maturity. And if I think into the future where we're going to be making multiple different predictions and we might want to easily swap out what type of prediction, I think we're going to make prediction the resource that we want here. I think that makes the most sense. And then we're going to make sure that we know that the method that we want is post. You could accept multiples here, but I'm not sure why you would. Because generally when you're creating a RESTful API, at least when I'm creating a RESTful API, I like to create, if I'm going to have a resource route like this, I'll generally have 4 verbs at the most that I use with it. I'll have a get to get this. I will have a post to create data or send data to it. I'll have a put if I'm trying to update data that I've already created, and then a delete if I'm trying to get rid of it. So I almost never create a single resource like this and then tell it that I'll accept multiple methods within the same function declaration. I would create multiple function declarations for that. So let's call this get prediction. And let's see. I think we need to just get image data. Yeah, so let's go down and work bottom up and get image data. We're going to pass in the request that's coming in, and there's a couple of steps in here. One is we're going to get the actual image data that's being passed, and so I will call this, these names are all going to be very similar, but we're going to assume, or we're going to dictate that the image data will be passed as multi-part form data, or a file. And we'll call it image data. And then we're going to create a unique file name. Pardon me. Save it as a PNG. For this purpose, I'm only going to accept PNGs. If they can't be converted to that, it just won't work. You could make it more sophisticated if you wanted to. But for this, we can just assume we're getting PNGs. And then I'm going to use UUID and create basically a unique .png file name. Image file data.save, and we'll give it the file name. And this should save the image data locally so that we can use the Keras image pre-processing utilities to get it in the format we want. So now we'll say load image, and we'll give it the file name. And now here is another opportunity for optimization. So if we look back at our target size, it's 256, 256. And so if we wanted to, we could take this target size and put it in some kind of configuration file, or read it in dynamically so that we wouldn't have to declare it here and here. And I think that would be a good optimization, but for the purposes of getting this up and running, I'm not going to do that. Image matrix is image to array, and so this has the file data, and we're actually going to convert it into an array of numbers so that we can pass it into our model. And then the last thing we want to do here is clean up the image file that we saved. We don't want to just start saving a bunch of image files in our local directory and then we exhaust all of our disk space. And I think that's all we need. Image matrix, yeah. So we'll return that. I think up here in get prediction, all we really need to do is get our image matrix, and we'll say get image data, give ourselves some space to work here, and then we'll use that to make a prediction. And obviously we need to pass in the request here. So the prediction will be the predictor dot predict, and we'll pass in the image matrix, and then we will just convert it to JSON, and prediction dot toList. Now I didn't mention we need to call toList to change it from a NumPy array to just an array of number, or just a list of numbers, so that it can be converted to JSON. But that is it for our service. That's all we really need to do to load up the model that we trained and make some predictions. So I think now let's try to run this thing, and let's see what kind of predictions we get out of it. Before we do that, we probably want to clean that up, right? Alright. Yeah, so now let's try and run it and see what happens. Okay, I paused the video and fixed a couple of bugs there. We had the wrong path to the model. What else? I think I moved this service was under the providers directory and needed to be directly under services. and import OS was not, I had deleted the OS, and then methods was just method, but I think the service is working now. So let's just do a new terminal. Let's pull this over and give us a little bit of room to work with. And let's say vision and services, and then we should be able to use Flask to start this up. Now, a word of warning here, using the built-in Flask web server is not recommended, and it'll give us a message, but if we give it a name, or we tell it what app it is, and then we say Flask run, it should start our service up. And this is all NumPy stuff, but this is what I was talking about. Do not use it for production deployment. We'd want to use something like Apache or Unicorn or something like that. But we do have a service running here on a port 5000. And so what we can do is let's try to post some images to it and see, well, let's see what it predicts, I guess. So let's get to our validation folder. That'll be an easy image directory to use for this. Maybe in the next video we'll actually create a UI where we can upload some images that it's never seen before to test. But let's, feed our validation images in and see how it does on them. So code vision, data validation, plant maturity, and we'll start with juvenile. I think that's the first one that the first class in the list. Let's do an ls here and see what kind of, okay. So let's use curl here, and let's use a post verb. Let's send a header with it to tell it the content type, and we're going to use multi-part form data. Multi-part form data. I think that we're going to tell it what image data to use. Let's use 12345.2.png. I think that'll work. And then tell us where the service is. Yeah, that's not even close to valid. Let's try that. And then we decided that it was going to be prediction plant maturity, I think. Let's see what happens. Oh, what did I do? What did I do here wrong here? Let's think. Image data. Option F is badly used here. Why is option F badly used here? Because I used a colon and not an equal sign. Alright, so we sent the request, and we see over here, it loaded up the model, and you can see it was a pretty slow operation. I think if we send it again, it should be faster, and it is, because we've already loaded up the model. So now let's change into the seedlings validation directory, and let's see, do we have the same file here? We do. Let's see if we get a different prediction using a different image. It looks like we do. I mean, it's, yeah, so here it's predicting juvenile, here it's predicting seedling. It's by no means definitive, but I do think that gives me enough confidence to move forward with creating some kind of UI where I can upload different images that it's never seen before, and see if it can make some good predictions. So I think I'll do that in the next video. For this video, if any of this was helpful, please like and subscribe. And if I misstated anything, did anything wrong, or if there's, a better way to do it or a more efficient way to do it, please let me know in the comments so that I can learn something. But otherwise, thank you for watching, and until next time, see ya.